Hi everyone and welcome back. So today we're going to look at Unit 6.9, Volume of Prisms, and this is page 580. Alright, so our objective for today is just exactly what the title says. We're going to find the volume of prisms. Find the volume of prisms. My voice is still kind of wonky. I'm doing several of these videos in a row, so sorry if it's a little weird. All right, let's go ahead and take a look. So when we find the volume of an object, what it means is like how many cubes, so how much space is it taking up, all right? So basically what it means is how many cubes would fit inside, okay? All right, so for this one, for the volume of a prism, we have the volume, which is capital V, and then equals, capital B stands for area of the base. Area of the base, okay? And then H stands for the height, all right? So if it's a regular box type, meaning everything's rectangular or square, then you just multiply 3 times and you're good, okay? Otherwise, if it's triangular, you're gonna have to find the area of the triangle first and then figure out what it is, okay? And you can also use this with nets, okay, if that helps you. And for some people it does, for some people it doesn't. Okay, so for this one we're going to find the volume of the rectangular prism. So it doesn't matter which one you pick, you need to pick a base. So I'm just going to say it's the bottom. And so we're going to say it's 3 times 4.2 times 5. Okay, so let's go ahead and type that in. So 3 times 4.2 times 5. And we get 63. Okay, and then centimeters, and this time we're finding volume, so it's in cubes. Okay, again, volume literally means how many little cubes, so like a 1 centimeter cube, okay, not very big, but if you have one cube that's 1 centimeter by 1 centimeter by 1 centimeter, then it would take 63 of those to fill that thing up. Okay, that's what that means. All right, so let's find the volume of a rectangular prism with a length of 10 feet, a width of 13, and a height of 21. So in this case, we're multiplying all three together because it's the same as length times width times height. You guys probably remember that from 4th, 5th, and 6th grade. Okay, maybe even as early as 3rd grade. So we're going to have 10 times 13 times 21. All right, so let's do that. So 10 times 13 times 21. And we should get 2730. And we're in feet, so it's cubic feet. All right, let's try to need another example by ourselves. So go ahead and pause it. And let's take a look. So we have 8, 16, and 25. All right, so again, it doesn't matter which ones you pick first. It's all going to come out the same. So 8 times 16 times 25. So let's do that. So 8 times 16 times 25, and we should have got 3,200. And in this case, we're in centimeters, so cubic centimeters. Okay, and that's it for those. Okay, pretty easy overall, as you can tell. All right, now we're going to move into the triangular prisms. So the triangular prisms are just a little bit harder, and that's because you kind of have to dissect everything and see what's there. Okay, so in this case we have 2 triangles and we have 3 other sides. Okay, so what we're going to do is we're going to find the area of the triangle plus, and then or not plus, I'm sorry, just times. Okay, times, and then the height of the solid. Okay, so how do we find the area of a triangle? Well, if you remember from the previous lesson, it's 1/2 base times height. Okay, so and then we're going to times that by the height of the solid. So the height of the triangle means how tall the triangle is. The height of the solid means how big the whole thing is. Okay, so 1/2 of course is 0.5. Okay, now we need the length of the base. Okay, so here's my triangle right here. All right, I need the length of the base. So the base would be this part right through here. So that's going to be 6. And then how tall is the triangle? Well, the triangle is 2 centimeters tall. All right, times, now I need how tall the solid is. So if you kind of look at this as a like an office building, okay, how tall is the office building? Is it really only 2 centimeters tall? No, that's how like long the roof part is, right? Okay, how tall is the building itself? It's the 7. Okay, this is the solid height right here. That's our solid height. So we're going to times it by 7. So basically what you're doing, students usually end up piecing together is, what you're going to do is you're going to times all 3 numbers together and then just take half of that. Does everybody see that? Does everybody see that if I took this and then duplicated it to where there was 2 of them and pushed it all together, it would actually make a rectangular one? Okay, think about a door stop. If I had 2 door stops and I push them together, that would actually make a whole like box looking thing, right? Okay, it's the same thing. You're basically multiplying those 3 dimensions together and then taking half of that. All right, so let's go ahead and type that in. So we're doing 1/2 of 6 and then times 2 and 7. Okay, and I come out to 42. And that's going to be cubic centimeters. Okay. All right, let's go ahead and look at the next part. All right, so for this one, again, we need 1/2. Okay, and then I need the length of the triangle. So the length of the triangle is 6.5. How tall is the triangle? It's 8. And then how tall is the building? In this case, it would be 15 inches. Okay, or as I said, really you're just taking half and then times all of the other 3 numbers. Because it's all multiplication, the order doesn't matter, right? Okay, so 0.5 times 6.5 times 8 times 15. All right, that makes it 390. And we're in inches, so cubic inches. All right, let's try 2b by ourselves. Okay, so go ahead and pause it if you haven't already done so and did the 2a one. Go ahead and pause 2b and try that one by yourself, and then come back to me just as soon as you're ready. All right, let's go ahead and take a look. So it'd be 1/2. The base of the triangle is 6.5. The length of the triangle is 7. And then the building is actually fold over this time, so it would actually be 5.2. Okay, does everybody see that? I know that's kind of hard for some people to visualize. So it's like the in an earlier lesson I talked about how it blows over on its side. It's like laying down. Okay, your head is always the top of your body, right? It's just sometimes when you're laying down, the head is actually left and right instead of up and down, right? It's all the same though. Okay, so then when you type those in, we should get 0.5 times 6.5 times 7 times 5.2. And that came out to 118.3. 118.3, so that's cubic millimeters then. All right, let's go ahead and try this one. Okay, so it would be 1/2. And then the length of the triangle is 2. How tall is the triangle? That's 5. And then how tall is the building? Well, our building fell over in the wind again. Okay, so it's actually only 3 inches tall. Okay, so we got 0.5 times 2 times 5 times 3, and that makes 15. Okay, and that would be cubic inches. All right, so again, the unofficial rule, but it does work as long as they don't give you extra information, because sometimes what they'll do is they will give you the slant part of the circle, or the slant part of the triangle. Okay, and you got to know, so if they give you 4 different numbers, you got to be able to figure out which one you don't need. Okay, that's why I don't always recommend just learning to multiply everything with 1/2. Okay, you do need to understand what the parts mean. Okay, so let's try number 3. All right. Okay, so we got a STEM question for all you STEM people out there. So this one's for you. And if you don't know about STEM, STEM stands for science, technology, engineering, and mathematics. So basically it's a question where they kind of mix all of everything kind of together. Okay, So it says a room air conditioner can cool a room with a volume of 1,600 cubic feet. If a room has a height of 8 feet and a length of 16 feet, what is the maximum width of the room? All right, so air conditioners can only put out so much cold air. Like, that's why some systems are small and some are huge, because everyone's houses are different sizes, so you gotta buy the right size for your house. Otherwise, you'll either have too much power, which can cause just as much problems as not having enough power to properly heat and cool. All right, so they already told us the volume. So a room, of course, is just a box, so it's volume equals, length times width times height. So they already told us the volume. It is 1,600. Okay? It says it has a height of 8 and a length of 16. So I know 16, I don't know the width, and I know the height is 8. So if we're trying to solve for the variable w, then how am I going to solve this? Well, we're going to put our like terms together first. Let's figure out what 16 times 8 is. And it looks like 16 times 8 is, oh, maybe mine just froze on me. I don't know what happened there. Okay. My equals button quit working. There we go. Okay, 16 times 8. 128. Okay, so this is going to be 160 equals 128W. We're going to divide that by 128. So 160 divided by 128, and we get 1.25. Okay, so 1.25 equals the width. So that would be feet. Doesn't seem like very big. Double check that just to make sure. Seems awful small. Oh, 1,600. There we go. That's why I'm like, that doesn't sound right. Sorry about that. 1,600. Okay, so it'll be 1,200, or 125. Sorry. I'm like, that didn't sound right. Always check for reasonableness, right? 125. There we go. Equals W. So 125 feet. Okay. Now remember, it's only in feet because we didn't find the volume. We found a dimension. Okay, so here we go on that one. Let me circle that, I guess. Make sure we can find it then when we look back. All right, let's take a look at the next one. A children's rectangular pool holds 17.5 cubic feet of water. What's the width of the pool if its length is 3.5 feet and its height is 1 foot? All right, so it's the same thing. So we already know that the volume holds 17.5. Okay, do we know the length of the pool? Yes, we know it's 3.5. Do we know the width? Nope, it says what is the width. Okay, so width. And then we know the height is 1 foot. All right, so for this one, we're going to combine our like terms. So that's 17.5 equals 3.5 W. We're going to divide that by 3.5. And it came out to 5. 5 equals W, so the width is 5 feet. There we go. Okay, 5 feet. All right, and that's the end of that one. Okay, so just remember whenever you're doing the triangular prisms, for the most part, you can pretty well use the rule of multiply all 3 of them and then divide it by 2. Sometimes if you're lucky enough, they'll just tell you what the area is. Not very often, but sometimes it's more for surface area. They'll do that for you just to save you some time. But anyway, so there's that. Thanks for watching. Have a good day, and don't forget to give me a like and subscribe. Thanks. Bye.